Alright, so this example 5 is another two clues problem, and I would like you to solve it and write out your solution and then videotape your solution. Just explain it, not thinking very long, like a couple minutes where you just, okay, so because of this I drew the triangle like this, and because of this I know the signs are like this, and so then if I use Pythagorean theorem, and huzzah. So, yeah, I look forward to watching those. So moving on, we're trying to develop the whole, what's called the unit circle here, is a shortcut to get a bunch of trig values. And so one important thing to note are the special ones that don't really even have reference angles, called quadrantal angles. A quadrantal angle is an angle that terminates on one of the quadrants, like right in between them, so it's either on the x or the y axis. So straight up, straight left, straight right, straight down. They have no reference angle because if I try to draw a triangle, it collapses. Either the base and the height are basically the same, either vertically or horizontally. You can't actually draw a triangle because the hypotenuse should be, usually we call it r, because it could make a circle like with a radius, but then the hypotenuse and one of the sides is the same. And so they have special things you just need to memorize, basically. And so find the value of sine and cosine of all the following quadrantal angles. Okay, so 0, the sine and cosine, although really we could do all of them. So sine of 0 and cosine of 0. Well, if sine of 0 is the opposite over the hypotenuse, and I didn't go anywhere, like 0 is, a 0-degree angle, is just right here. So the opposite and the hypotenuse are, well, they're kind of, I don't know. The opposite, there's not really an opposite. There's kind of just an adjacent. There's no y, right? The opposite is normally up here, right? This is normally the opposite. And so there is no opposite. And so sine of 0 should just be 0, which it is. Cosine of 0 then, well, there's the adjacent over the hypotenuse. The adjacent and hypotenuse are the same, so it should be 1, and it is. Pi over 2, that's straight up, and so we have kind of the opposite scenario. Sorry. So pi over 2 would be 90 degrees, right? Hopefully we could start thinking just in radians from now on, though. But pi over 2 straight up. So now the radius, or the hypotenuse, is basically the same as the y, which is the opposite. And so sine will be 1, and cosine will be 0. And then pi, sine of pi, cosine of pi. Similarly here, cosine is negative over on the left, because cosine is like the x's. Oh, well, the x and the r are the same, so there would be negative 1. And sine, there is no y, so it would be 0. I forgot when I did the first explanation that we talked about the x's and y. So 3 pi over 2, oh, and this is the same as 180. 3 pi over 2, that's the same as 270, that's down. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, etc. Back on up. So 3 pi over 2 is straight down. Oh, so sine should be, sine of 3 pi over 2 should be negative 1, because it went straight down. And cosine 3 pi over 2 is 0. And you just need to get all these memorized as fast as possible. So 2 pi, oh, well, 2 pi and 0 are the same thing. This would be 360 degrees, but that's the same exact angle as 0, at least as far as reference triangles. So 0, 1, 720, a whole nother rotation around. This is also known as 4 pi if we went back the other way. Okay, so that'd be 0, 1, so sine, cosine. Sine, cosine. 5 pi, okay, that's the same as 1 pi, right? Because it's 1 pi, then 3 pi, then 5 pi, right? So it's over here, and so it would be the opposite of it, that would be -1 and 0. So still no y there. So those are the quadrantal angles, and you need to be able to picture those very quickly. Maybe I could have done that a little faster, but yeah. Let's do some super fun geometry review. I just did this lesson in geometry, I don't know, a couple weeks ago. Not too long ago. Draw a 30, 60, 90 triangle and a 45, 45, 90 triangle. Okay. So let's see, 30, 60, 90. So I need kind of a shorter side, kind of a tall side, and a right angle. So to me, this kind of looks like a 30 and a 60. And then a 45, 45, 90, I need an isosceles right triangle so that these are both 45. If those are 45, then these are the same. Just saying. For each, scale the hypotenuse. Okay, so if you remember these, hopefully you remember these, at least a little bit, opposite the 30, if we call that just x, then the hypotenuse is always double that. It comes really quick from if I were to just, if I were to have made this into a 60, and then this would be 60, I'd have a equilateral triangle, and so that would be x, that would be x. Well, all the sides would be then 2x. So that's kind of where that comes from. And then Pythagorean theorem, x squared plus what squared is 2x squared. Oh, I end up with 3x. And then I have to square root it, so square root of 3x. Oh, yeah, so then this side is just x root 3. But now it says really quick, scale the hypotenuse to be 1. Okay, so if this is 1, then if 2x is 1, then x is, a half. Okay, so actually let me change colors here. Sorry. Shoot. Okay, this is then, if this is 1, then this is a half, and this is a half root 3, or we could call it root 3 over 2. That got a little messy, sorry. And then on the other one, normally we'd say, okay, 45, 45, 90, so that if these are both x squared plus x squared is 2x squared. The square root of 2x squared is 1x times the square root of 2. That was just Pythagorean theorem, but with a lot of confusing words. But then if I say that this equals just 1, if I want the hypotenuse to be 1, then these must both be 1 over root 2 and 1 over root 2. Now we usually rewrite that as root 2 over 2 for both of those. And so then the point of all of this then, if I want to know what sine of 30 or sine of 60 or sine of 45 or tangent of 45, etc., it should be a real easy, if I make the hypotenuse 1, what's sine of 30? Well, sine of 30 is a half over 1, the opposite over the hypotenuse. So sine of 30 is a half. That's a really sloppy half. Sine of 60 is the square root of 3 over 2 over 1. So it's just the square root of 3 over 2. Sine of 45 is is 1 over root 2 over 1. So it'd just be root 2 over 2. Tangent of 45 would be 1 over root 2 over 1 over root 2, so it would just be 1. It's so on and so on. And so we can get a bunch of our major 30, 60, 45s, all the trig functions really, because no matter what ratio these sides are, they always have the same ratio no matter how big they are. And so if we just did 1 as the hypotenuse, all the rest are just these nice, easy to work with numbers. Pythagorean theorem gets us the third, and there we go. So now, the idea here is we can then add that anywhere for any angle if we just go around in circles. That's how angles work. And so here is a beautiful triangle, or this is not a triangle. Wow. Go back to geometry. I teach geometry, actually. I'm just trying to figure out how to zoom this in. If I just look at quadrant 1, if I wanted to know the trig functions about a 30-degree angle, so if this was 30 degrees, right here, if I were to eventually have that intersect, it's supposed to intersect at that point, if I were to intersect this line, this circle, this is then what we're going to call a unit circle. If I just automatically make this be a radius of 1 rather than an r, and I just put in a triangle here, observe I have a 30-60 triangle. And so opposite the 30 is supposed to be a half, and opposite the 60 is supposed to be root 3 over 2. Well, that means that the coordinates of this point on this circle would have to be, well, the x-coordinate would have to be the square root of 3 over 2, and the y-coordinate would have to be a half, because it goes up a half to get to that point. Well, I could then do the same thing. If I wanted to make an angle go up 45 degrees, it would look like that. This would be a 45-degree angle. And if then I were to drop this down and call this still a radius of 1, because it's touching the same circle, now I would have that this and this are both root 2 over 2 because of the drawing I just did. And so this point would be the square root of 2 over 2, and this point would be the square root of 2 over 2. I actually meant to do one other thing right there, and that's, okay, so now coming over here, if I were to draw another triangle over here, whose, wow, let's try that again. I missed my other program, just makes a line. Whose reference angle is 30 degrees. This would happen to be all the data here for a 150-degree angle, is what I'm actually looking at. But I would be able to draw the same triangle over here, where if this is 1, so then this should have coordinates of a half tall in the square root of 3 over 2 wide. That looks so bad. But in this one, I'm on the left, and so x's are negative over there, so it should be negative root 3 over 2, comma, a half. And if I were to draw the same triangle down here, right? If I were to draw the same triangle down here so that it has a 30-degree reference angle, now from standard position, this would be 180 and a little more. This would be a 210. Or it could be a negative 150 if I went this way. And so on, but they'd all have the same reference triangle that would have the opposite 30 is a half, the adjacent's root 3 over 2, or the opposite the 60. And so this would be negative root 3 over 2 because I'm left, and negative a half because I'm down, and I can get the coordinates there. And this is how you make a unit circle. And so all these tick marks for 45s, all of these should all be root 2 over 2 and root 2 over 2. Just depending on the quadrant it's in, you change some SIGNs. What about the other one? We haven't done the other one yet. So the other one in, let's see, I haven't done blue. The other one in blue, this would represent, what would that represent? A third, 2/3 of the way. Oh, this would represent a 60-degree angle, or a pi over 3, because it splits it into, if this whole thing is pi, then I have 1, 2, 3 pi over 3. So that's that whole idea. Okay, anyway, so if that's 60 and then I drop this down, well, if that's 60 and that's a right angle, then this would be 30 up here. And so this would be a half. This would be root 3 over 2. Well, the half on the bottom, that becomes the x-coordinate here, a half, and the y-coordinate would be up root 3 over 2. And then if I were to take a 120-degree triangle, or angle, that would just be the one over here, so that this is now the 60 degrees, if this were 120 degrees. And so this should have the same coordinates. It should also be opposite the 30 is a half, so the x is a half, but I'm left, so negative. And then the right, root 3 over 2. So this is all the unit circle is just figure out if I made the hypotenuse is 1, what would the coordinates be? Because then those coordinates are simply the x-coordinate is always the cosine at that number, and the y-coordinate is always the sine of that angle, and the tangent is always the y over the x, always. And now we're going to bring back radians for the win again. So radians are unitless. That's very helpful because then I just have 2 pi's. I don't have to have these pi's over 180s. We have to have a 2 pi anyway because it's how you convert to like a circumference. But now this is where radians really are great. Really are great. And in my own as a professional math teacher, right? So this angle here technically was 150 in here. I'm trying to re-highlight that one, whatever. I made it worse. 150. That's hard to remember what that is. But in radians, right? So the shallow angle, the most shallow angle in radians, this is pi over 6. So this would then be this would be 6 pi over 6. And so that would mean just short of that, this one here would just be 5 pi over 6. This would be just a little more, so this would be 7 pi over 6. And this would be just short. Oh, there's actually a line here. So this would be just short of all the way, so this would be 11 pi over 6. All of the 45s are all pi's over 4, so this is something, this one here would be something pi over 4, and something pi over 4, you can't actually see that, huh? And something pi over 4, this is 1 pi over 4, 2, 3, 4, 5, 6, 7, 8 pi over 4. So this would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. And here's one great way to know another reason. What is tangent of 300? Oh man, where's 300? Let's see, 300 is 60 short, so it's 60 short of, oh, so this one down here is this is the 300. Okay. But if I just said, I didn't actually do these ones, but if I just said, what is 300 in radians, that's 5 pi thirds. So if I said, what's tangent of 5 pi thirds, I know, oh, pi thirds, which I didn't actually do. This one's pi thirds, and 2 pi thirds, etc. But any pi thirds, a half root 3 over 2. And if you want tan, if I have a half root 3 over 2, it's the height, or the y, over the x, which is a half, which is just root 3. Oh, so tan 5 pi thirds is just root 3, but then it's in, let's see, 5 pi thirds is in quadrant 4. So let's see, all students take calculus, cosine's positive. Oh, so tan's negative. So negative root 3. And you can just think through all that in your head. Maybe you weren't tracking that at all because I didn't actually mark anything, I just said it. But that's what our brain needs to start thinking. So let's run through a few of these, and you're going to practice a bunch in Delta Math, and then we're going to practice, and you just got to have some of these just automatic as soon as possible. So we're going to be doing some time stuff in Delta Math, inch by inch, it's a cinch. There's one key idea here. Actually, there's 3 main things to do. Practice, practice, practice. Gotcha. Okay. This is fun and easy, right? This is fun easy. Sine of pi over 4. So quickly, you should think, okay, pi over 4, those are all the root 2's over 2, root 2 over 2. And then sine is which? The y coordinate, so root 2 over 2. Not that mattered. And then, let's see, pi over 4 is in quadrant 1, so positive, done. Sine of something, pi over 6. Okay, pi over 6 is a shallow angle originally, so the distance out must be longer than the height. So I'm trying to say there is pi over 6 is very shallow, and so this distance has to be bigger than this distance. And so if they're the same, then they're root 2 over 2. Oh, you can't see that, but if they're different, root 3 over 2 is bigger than a half, right? Because root 3 is bigger than 1. They have the same denominator. Okay, so back down here. So that's the basic pair. Whenever I see pi sixths, I want sine, so I want the y. So a half. Quadrant. This is in quadrant 4. The y's are negative in quadrant 4, so negative a half. And this is kind of how you start thinking through the unit circle. Cosine of something, pi thirds. Pi thirds are the steeper one, right? This would be pi, this would be pi sixths, this would be pi thirds. So pi thirds are taller than wide, so this one is taller, so the root 3 over 2 is the y in a half. Oh, and I want cosine, so this should be a half. Now where's 2 pi thirds? Okay, so this is 3 pi thirds, 0 pi thirds, 1.5 pi thirds. Oh, so it's this one right here. Okay, 1, 2, 3 pi thirds. 1, 2 pi thirds. So it's in quadrant 2. Quadrant 2 is left, so cosine's negative. Okay, we're getting it, right? Fun? Easy? Fun easy? Not yet? Maybe? 3 pi over 2, that's pi over 2. Let's see, pi over 6, pi over 4, pi over those, I don't know. Oh, this is one of the quadrantal angles. Right. So this is straight down, right? 3 pi over 2 is down here. So cosine is the x, so 0. Okay, switch colors even. Let's see, sine pi fourths, root 2 over 2, because x and y are both root 2 over 2 at pi over 4, and I want sine, which is one of them, so it's the y. And then let's see, 3 pi fourths is in quadrant, well, 4 pi fourths is the 0. So this is 1, 2, 3, 4, 5 fourths. So I'm right here. So sine is, the y is positive, is root 2 over 2. Yerp. Yerp. I'm having slightly too much fun. Actually, that's not possible. Sine of pi over 3. Pi over 3 is the steeper, or like the slightly bigger one, and so that's where the root 3 over 2 is the taller, so it'd be a half root 3 over 2. And let's see, sine is the y, so root 3 over 2, and I'm in quadrant 1, so I'm done. Hey, that kind of like rhymed. That's almost the same word, done, one and done. That's like a thing, right? Cosine 5 pi over 6. Okay, pi over 6, that's where the way out is longer than the way up, because pi over 6 is shallow. So that's the normal coordinate, so I want the y coordinate of that. And 5 pi over 6 is left and slightly up, so negative, because it's cosine, and that's the x. Cosine of pi. Cosine of pi, that's straight over here. Cosine's negative 1. Sine is 0. Okay, there's one more. We are going to practice these with tan and then secant, cosecant, cotan. I just want to keep getting down the basics. Okay, pi over 6. Pi over 6 is, let's see, pi over 6 is the shallow one, so it needs to be shorter than it is long. And I want sine, so a half. 7 pi over 6. This is 6 pi over 6. And this is 12 pi over 6. And this is halfway between 6 and 12 pi over 6. Oh, so I'm somewhere over here. Specifically, I'm like right here. So negative, because I'm down. I'm in quadrant 3. Everything's negative. Well, except for tangent, because that's 2 negatives. And that's, I think, is a good place to stop. You just need to practice these. Yeah, over here we have a whole big blank unit circle they'll have you do at some point, and then we're going to make the same observations we just made and add the others, tan, cotan, secant, cosecant, etc. And we'll keep adding to this. Yay.